Hi guys, welcome back to In Case of Econ Struggles. Today I'm going to keep talking about simulations with econometrics. I'm going to talk about some basics for how to set up simulations in Stata. So I've got some code right here. I'm going to post that in the description below. But what I want to do in this video simulation wise is talk about the law of large numbers, which I talked about in the most previous video. So I'm going to show you how we can use simulated data in order to show the law of large numbers. And so what I'm going to do for this simulation is the first thing I'm going to do generally is I'm going to set the number of observations I want overall in my data set. So in this case, I want 10 million. I'm going to do this thing where I set the seed of some random number. What this is going to do is this is going to make sure that when I run my code every time, I'm going to use some random numbers. So this will make sure that my data set should come out the same every time so that it's replicable across sort of when I open Stata or not. And so if you send this to your friend and your friend runs this, they should get the exact same numbers that you did. Now what I'm going to do for the law of large numbers, we're going to start with means. So I'm going to set the true value of the mean to be 15, just like I did in that past video. And then just like in that past video, I'm going to generate my observations. I'm going to generate some x as that local mean or that 15 plus some noise. That noise is going to be normally distributed. This is what our normal, just normally distributed. I'm not going to put anything in the brackets, so this is equivalent to saying 0, comma 1. So mean of 0, standard deviation of 1. And I'm just going to generate an observation number, which is going to be equal to underscore n. I'm going to do that so I can take samples at different sample size by restricting which data points I use in a given sample. Okay, so now we're going to show the law of large numbers. So what I'm going to do is I'm going to run this over a bunch of different samples, and I want to collect the mean basically every time. There's a couple different ways to do that. I think the easiest way is to just use a temp file. So I'm going to make this temp file. It's going to start empty. It's going to be called means. And now what I'm going to do is I'm going to have a bunch of different samples of different sample sizes. Each time I'm going to take the mean with that sample size, and we're going to look at how the mean changes when I increase the sample size. So I've just picked a bunch of different values. You could be more methodical and do like every 100 or every 1000. But I'm going to start with a sample size of 1 all the way until I get to 5 million. I could also do 10 million in there if I wanted as well. But on a graph, it starts to get sort of busy and sort of far away from 0 if I include 10 million. So I'm just going to exclude that for now. What I'm going to do for each sample size is I'm going to do this quietly just because it'll help Stata run a little faster. But I'm going to sum my x variable for the sample size less than or equal to n. And what I'm going to do is I'm going to store that sample mean. It's typically called x bar, so maybe I'll call it x bar instead of x hat. So x bar is our mean. Then I'm going to append it, and then what we're going to do is I'm going to sort of graph x bar across the sample size, and we'll see what it looks like. So I'll go ahead and run this code like this. We'll look at what happens. Again, quietly, it's not going to put out anything, but it's going to be running in the background. And so now that we've got it, let's go ahead and browse. And so what you can see is it started with the big sample size of 5 million. And then as I go towards 1, you can see that this x bar is moving further and further away from 15. So that's kind of nice. Might be easier to graph it. So here's just some code for graphing it. Just throw it in the graph. And if I throw it in the graph, again, you can really see that we start with the sample mean that's far away from the truth, which is 15. And as we increase our sample size, we get really, really close, and basically we hit 15 every time once you get something above, say, like 1,000 observations. Okay, so that's just showing the law of large numbers with means using simulated data. Of course, in that last video, I also talked about regressions and how the law of large numbers applies to both beta and alpha, or the matrix beta in a regression, and so let's show that as well. So again, very similar setup where I have these observations. I'll use a different seed for this simulation. I'm going to set the parameter values. So in that last video, we said that alpha was 1 and beta was 2. So now I'm going to generate an x variable, which is just going to be our normal 0, 1. And my y is just going to be this alpha plus beta times x, which is the truth, plus some random noise, again, normally distributed 0, 1. And then if I do that, and we can think whether or not OOS is going to recover the true parameter with the whole sample. So I'll just run that regression, and you can see that I get something really, really close to 2, something really, really close to 1. And so I know that using the entire sample, I'm going to get the truth. And now the question is, do I get closer and closer to the truth as my sample size increases? So again, I'm going to do this temp file, and maybe I'll start off with just a test run of this loop. So the test run of this loop will just say, okay, for 10, I'm going to preserve, I'm going to do this regression, and then what I'm going to do is I am going to once again store my beta and my standard error. I'm going to store my alpha, which is this constant or underscore b underscore constant and my standard error. And then I'll just look and see that this looks all good to me. So I'll just run everything from the top just so we can take a look at it. And you can see if I go into this data, that again, I've got my sample size. These look about right. These look about right, just comparing to this table. And so now I'm going to run it for the full loop, and I'm going to make it a little easier on myself. First way I'm going to do that is I'm just going to uncomment this sample size that I'm going to run. I'm going to leave this commented just in case I need to do any more testing later. I'm going to add a quietly in here for the same reason that we did before, just make it go a little easier on my machine. And I'll go down and I'll make sure everything looks good. I'll add the end of the quietly right there. And now I'm all good, and I'll go ahead and run this guy. So I'll run it from the top. And now that I've ran it, what I'll do is I'll get these confidence intervals, these 95% confidence intervals for both my beta and my constant, which I'll just use as the estimate plus and minus 1.96 times their standard errors. And now what I'm ready to do is I'm ready to make a graph. And so first I'll start with beta. I'm going to plot both the coefficient estimates as well as the upper and the lower end of their confidence intervals with their sample size. And we'll just take a look at what this graph looks like for beta. And if I take a look at this graph, what you can see is that once I get to a pretty large sample, again, the confidence intervals are just so small you can't see them on this graph. But we've basically gotten to the truth in terms of our beta. And so we would say that this shows that the law of large numbers holds for beta. Do the same thing for alpha or for our constant, and I'll just throw that graph in, and you're going to see a very similar picture. So again, I'll throw this code in the description as well, but these are just two examples of how to set up basic simulations in Stata. As we keep talking about different econometrics topics, I'll start talking about simulations. I'll just throw it at the end of those videos so that we can keep working on our simulation skills in Stata. If you got any questions or something specific that you want to see simulated, put that in the comment section below. But if this video or these videos in general helping you out, please like and subscribe. We'll see you next time for another case of econ struggles.